This video is about the reactivity series and how metals are extracted from ores in their natural state. So we've got from most reactive to least reactive a selection of elements which are most commonly talked about in GCSE. And we've also, although most of them are metals, we've also got carbon and hydrogen shoved in this list at points. And that's important to know where they fit. Now, first of all, let's talk about how the metals naturally occur. With the exception of really unreactive precious metal like gold, these elements will all occur naturally in a natural form called ores, usually compounds with oxygen in rocks that have to be mined out and then processed to extract the metal. Now, how we extract the metal depends on where it falls in the reactivity series. As a rule, the further up the series it is, the more energy is going to be needed. But even within that, or beyond that, the ones that are more reactive than carbon cannot be extracted by a competition reaction with carbon. Carbon's always going to lose to these guys. But anything to the right of carbon, zinc on downwards, can be extracted in a blast furnace. Now, it's going to take more energy to get zinc out of its ore than it will to get copper out of its ore in a blast furnace, but all the same, carbon will do that. So that's the method for extracting below carbon. Above carbon, you need a different method, so we use electrolysis. And again, potassium is going to take a tremendous amount of energy to extract through electrolysis. So that's the kind of summary of it. One other quick point to make is why bother with hydrogen? Well, when you're looking at equations with electrolysis, knowing whether your element is above or below hydrogen will tell you whether it's going to be produced at the cathode. So electrolysis with copper salts will produce copper, likewise silver at the cathode, but anything above hydrogen, the cathode will actually produce hydrogen rather than the metal. So that's the other point to know. Thanks very much for watching.